Plants may seem still, but they are constantly on the move, responding to their environment in fascinating ways. While they cannot walk or relocate, they use tropic or nastic movements to grow, survive, and reproduce. Tropic movements are directional, meaning plants grow toward or away from a stimulus. These movements help plants find essential resources like light and water. Phototropism is the movement toward light. Shoots grow toward light to maximize photosynthesis, while some roots grow away from light to stay underground. Gravitropism is the movement in response to gravity. Roots grow downward to anchor the plant and find water, while shoots grow upward to reach sunlight. Thigmotropism is the movement due to touch. Climbing plants like vines wrap around supports when they come into contact with them, helping the plant reach light and stability. Hydrotropism is the movement toward water. Roots bend toward areas with higher moisture to ensure that the plant remains hydrated. In contrast to tropic movements, nastic movements are non-directional, meaning they occur regardless of the stimulus direction. These movements are often rapid and are driven by changes in cell pressure. Thigmonesty is the movement due to touch. Examples include Mimosa pudica, which folds its leaves when touched, and the Venus flytrap, which snaps shut when insects trigger sensory hairs. Nyctinasty are sleep movements. Some plants display rhythmic movements based on the time of the day. For instance, clover leaves fold up at night and reopen in the morning, a behavior thought to conserve energy and protect delicate tissues. So why do plant movements matter? Plant movements are crucial for survival. They allow plants to find light for photosynthesis, search for water, capture insects for nutrients, and protect themselves from external threats. Although these movements are often slow and invisible to the naked eye, they demonstrate how plants actively interact with their environment.